Hello everybody. I decided to make another video for you guys for this answer key, or for the review guide, make an answer key for you. So I'm going to take you through some of the questions, see if I can do as many as I can in a certain time period. Okay, but starting out, the first ones here kind of just have some information about polynomials that you have to know. So number one, number two should be fairly simple. It says, what's the degree of the polynomial? So remember, for the degree of the polynomial, we have to look at each of the terms individually. Okay, so whichever one has the highest combined power is the degree of the polynomial. So the one with the highest degree or highest power is that one. It's the cube. So what's the degree of the polynomial? That would just be a third degree polynomial. Okay. Second one, how many solutions do they have? That is exactly the same as the degree. So remember, I said in class, I said, if you want to know how many answers you're going to have when you're done, you look at the biggest power. So that would be this one again. So that means it's a third power, so it's 3 solutions. Okay, or 3 x-intercepts. Then the next one down here, okay, degree is even or odd, so this goes along with that packet that we did one day. Both of the ends are pointing down. So we look at the end behaviors here. We got that one is going down, and that one is going down. Alright, so if they're both going the same way, that means it has to be an even function. So that's like a parabolic type thing, where they're both going down or they're both going up. So this one would be an even function. Alright, and then for the second part, leading coefficient is positive or negative. Look which way the ends are pointing. They're both pointing down. Okay, so down is associated with negative values, so that means it's a negative leading coefficient. Okay, and then how many real solutions? That means x-intercepts. So how many x-intercepts do we have? Well, let's count them. We got one here, okay, and then we got one here, and then we have one here as well. Okay, so there are 1, 2, 3 x-intercepts. So that's how many real solutions. Alright, and remember, if we wanted to go a little bit further, we could tell how many real solutions this is going to have by counting the number of terms, or we could tell the least degree of the function. So it would be 1, 2, 3, 4. So there's 4 terms. We can count this as a term because it kind of turns flat and then goes back up. So there are 4 terms. So if we want to know the least degree, you take that and you add 1. So it would be 4 plus 1 equals at least a 5th degree polynomial there. Alright? So that would kind of lead us into number 4 here. For each of those, we want to graph these, or look at the graphs of the functions, and then fill in the information below. Alright? So we want to estimate the turning points on the graph, so that means estimate the max or mins. Okay? And determine if it is a relative max or min. Estimate the x-coordinate for every 0. Determine smallest possible degree and domain and range. So it's kind of a lot for each one of them. I'm just going to do a couple of them. Okay, this one down here, it's just got a lot of information to it because it's got a maximum there, a minimum there, maximum there, minimum there, maximum there, minimum there. So you'd have to write out all those points. And I'd be okay if you just labeled them on the graph rather than writing them in the box below, because that might be a little bit easier. But let's take a look at the first 2 of them, okay? So I'm just labeling about where I think my maximums and minimums are going to be on these graphs, okay? So let's look at the first 2. So there, there, there. Alright, so estimate the turning points on the graph and determine if it's a relative maximum or a relative minimum. So I'm just going to write minimum, maximum, okay? And I'm going to write the points next to it. So I'm going to look at my minimums first. So here, if my 0, 0 is right there, then I'm going back 1, 2, and about, we'll say 2.6. Say 2.5, not that big of a deal. So negative 2.6, comma, we are down 1, 2, 3, 4. So negative 2.6, negative 4. That's one of them. We have to do this other one here. So it's about 1.5, negative 4. So it'd be positive, positive 1.5, negative 4. That would be my 2 minimum points, which are here, and they are here. Those 2. Okay, maximum, we would want this one. So 1, 2, 3, negative 3.5. comma, we're down to about a half, so negative 0.5, that's one of them. Then the other maximum would be up here. So if 0, 0 is here again, we're negative 1, negative 1, positive 3. So that would be my maximum because that's a high point. Okay, this would work. This is good enough because you're labeling the turning points and you're saying if they're a maximum or a minimum. All right, so then we need the zeros. Okay, this is very similar to what you guys had to do on the last test, but I don't think I asked you to write out the zeros. I wrote them on there for you guys, but I'm asking you to here. All right, so estimate the x-coordinate of every zero. We have that one right there, which we could say is close to negative 2, so I'm just going to estimate and say it's negative 2, 0. Okay, and then we have this one, that is 0, 0. And then we have that 0 right there, so it's 1, 2, 3, say 3.2, 0. So those are my zeros. That would be, if I labeled it on the graph, that would be here, here, and here. Okay, so this would be part A, this would be part B. Part C says determine the smallest possible degree. Well, I just kind of did that up above for you, so you count the turns. So 1, 2, 3, 4 turns. So the possible degree is 4 plus 1 equals a fifth degree. And remember, that's the least possible. What that means is this could be more than a fifth degree, because if you guys remember from that packet that we did, the higher the degree, sometimes the more turns you get, or the flatter the curve kind of gets. Because we had those like x to the 8th, and the x to the 8th was kind of like a really flat at the bottom. It was kind of a boxy shape. So you just count the number of turns and add 1, and that tells you the least degree. Okay, so then we need domain and range. And a lot of the times for these, both of them are going to be all real numbers, except for when you get to an even degree. Okay, if we're an odd degree function, like this one would be, or this one over here would be, those are always going to be all reals for both. If you're an even function like this, remember we can tell it because it's going the same direction, then you have to figure out what that bottom point is going to be. So for this one, since it's an odd function, domain is all reals and range is all real numbers. Alright, so let's take care of this one quick. So maximums, minimums, I switched it around, that's okay. Maximums here, so my origin is right there. Okay, it's kind of hard to tell on these, I suppose. But my maximum is going to be about negative 0.51. And then my minimum would be these points down here. Okay, so it's 1, 2 and a half, so negative 2.5, and we're down to 3. So then that means this one is 1.5, negative 3. Okay, so that's A. B is the zeros. So we'll say my zeros are negative 1, 0. And 2, 3, so say negative 3 point, we'll just say 3.8, 0, and then we have 0, 0, and 1, 2, 3, we'll say 3.2, comma 0. So there's 4 of those, 4 zeros there. Alright, C, least degree, 1, 2, 3, add 1, so 3 plus 1 equals at least a fourth of degree. And then D is domain and range. So this is the one I said, since it is an even degree, it's going to have a certain range. So this bottom point, so we got to figure out where that is. So my range, this is my low point, I'm going up from there. So we got to figure out what this low point is. You should be able to kind of see that this is negative 3. So these are touching negative 3, so that means we're going to have y is greater than or equal to negative 3, because it's down there and it's going up. Alright? So those are the polynomial functions. That's what I'm going to expect when I give you one on the test, or the quiz, whatever you want to call it. It's going to have that information. Okay? Down here, perform the indicated operation, add, subtract, or multiply. So these ones down here should be really easy. Alright? This one right here might be the only one that has a little bit of a trick to it because it's a subtraction, but you should remember distribute the negative, and then add. Alright, so here it's just add like terms. So I have a 3x squared, I'm looking for another x squared to add right there. So it's 3x squared minus 7x squared. So that's negative 4x squared. Okay, and then, so that takes care of that, and that. Then we have a negative 4x plus 2x, so that's minus 2x. So that takes care of that, and that. And then 8 minus 5, negative 3, takes care of that. Alright, so then this guy over here, let's distribute the negative, and then add. So I'm just going to rewrite it for you guys. You don't have to rewrite it, I'm just doing so you can see it. So add like terms, I got y squared, so that gives me an 8y squared. I have a y to the 4th in here, I'm going to put that out front. So 8 minus 9, so that's negative y to the 4th. That was a positive 8y. Okay, so I know it's plus because that's a positive 8y squared. And then I have those. So negative 5 plus 2 is positive 2y. So that's that one. Alright, this was the only difference between the two of them. You distribute the negative right there, you take it through, and then you add. Okay? On to page 2. Very similar things here on page 2. So these ones up here, you're going to distribute the negative and then add. Okay, I'll do this one here because it's a little bit more complicated, but this one right here is just exactly like the last one. Alright, so if I want to rewrite this one so I can actually do it, I'm going to distribute the negative first and then rewrite everything out. So there, my negative has been distributed to the negative 4, or the 4 and the 2 right there. Now I just add like terms. So 3x squared, 5x squared, gives me 8x squared. 5x and 2x, that's a 7x. And then 2 minus 4, that's negative 2, plus 7, that is a positive 5. That's your answer. And some of you guys might be thinking, well, do I keep going from here? Do I factor? No, all you're doing is simplifying polynomials. You're not going to factor here, you just simplify those and you're done. Okay. Number 9, some people had some issues with these earlier. What you're going to do first here is you're going to simplify anything inside the parentheses, okay, which I can't, and then you're just going to multiply from left to right. So I'm going to have 15 times 5 times 5, which I'm going to have to get my calculator out for that. Okay, so 15 times 5 gives me 375. So that times that times that. So it's a negative 375. Okay, because that's the 15 times the 5 and the 5. You just multiply the numbers, multiply the x's, multiply the y's. So x times x gives me x squared. And then times x to the negative 13th is x to the negative 11. Because you're going to add like terms. Alright, and then the y, so y to the 15th, y to the 3rd gives me y to the 18th. And then I have to do one more step here to simplify it, because if I simplify these things, I cannot have a negative exponent. Alright, so remember, properties of exponents here have negatives in the exponents. This negative 375 does not move down to the bottom. There were a few of you guys that were like, hey, there's a negative, this bounces down. It only moves if it's a negative exponent. So this x is the only thing, that's going to go down because it has a negative 11 exponent. So we'd have negative 375 y to the 18th over x to the 11th. That is your answer. Okay? And if that doesn't make sense when you do it that way, then I would write all the numbers right next to each other, all the x's right next to each other, and all the y's right next to each other. So it'd be like this: 15 times 5 times 5, that's a negative 5. And then I have x times x times x to the negative 13th. And then we had, I'm running into my other problem, so I'm going to write it down below. I had y to the 15th and y to the 3rd. You're just going to be multiplying all the numbers, multiplying all the x's, multiplying all the y's. It's not distributive property, because some people were like, boom, boom. It's not distributive property. Okay, so number 10, with this one, you're going to simplify inside the parentheses and then apply the exponent of 2. So if I simplify these, 40 divided by 20, well, remember when we did these in class, I kind of rewrote a new fraction. So this would be 2 over 1, and I don't really need the 1. So then this would cancel with 2 of those, and then this would cancel with 7 of those. So I'd have 2x squared over y to the 7th, and then I had that exponent of 2 on the outside. Then I just square everything. So I distribute my exponent to everything. Alright, so 2 squared is 4, x squared is x to the 4th, y to the 7th squared, so you multiply exponents, that's y to the 14th. That is your solution. Alright, these ones are a little time consuming, so I'm just going to kind of go through them. 14 and 13 are exactly like the ones that I just did, so exactly like 9 and 10. Should be able to get them from the answer key that I had in class, but I'll do 11 quick here because it's multiplication. 11 and 12, so that's multiplication of polynomials. So 11, this is actually the distributive property here because we see the subtraction and addition sign. Alright, this is distributive property. This up here is not, that's not technically considered a subtraction sign here, that's considered a negative 5. Alright, so here we're going to distribute into all three of them. So it's like negative 10xy times this one first. So that gets me to negative 40 x squared y to the 4th. And that comes from x times x, y times y cubed. Okay? And then the next one will give me a positive 70 x squared y squared. And then the last one would give me a negative 90, 10 times 9. I only have a single x and I have y cubed. Alright, now after you're done with that, you're going to look at this and see if you can add any like terms. Okay, some of you guys might try to add exponents here, but you can't. You can only add like terms. Alright, like terms have to have the same exponents and powers. So I have an x squared y to the 4th. There are no more of those here. X squared y squared, there are not any x squared y squared. There's an xy cubed. There are no other xy cubes, so you cannot add any of these terms together. Okay, so that would be your final solution. Alright, 12 is a multiplication of polynomials. So you're going to take the 5a cubed and run it through there. Alright, so that's 45 a to the 4th b cubed. That's the first one. And then negative 25 a to the 5th b squared, and then a positive 10 a to the 6th b. Alright, so that's just taking this term through there first. So 45 a to the 4th b cubed, so take it times that, times that, times that. And now we're going to take the b squared through there. Alright, so b squared is going to go through there. Try to make a couple different lines here so you can see what we're doing. So b squared runs through there. So it's 9ab to the 5th. Alright? And this is where I kind of said write it out cascading. If you see another one that matches that, I don't think you're going to have any terms that match here. So I'm just going to write it off to the side. So it would be 9ab to the 5th. And then to the next one here, it would be minus 5a squared b to the 4th. And then to the next one, multiplying these two here. So it's 2, so plus 2, a cubed, b cubed. Then look, see if you have any like terms, which I doubt you will. If you don't, then circle that because that is your answer. Okay? Alright, so 13 and 14, you should be able to kind of figure that out. I'll work through it quick so you can see it. That'll be a negative 34, that's 17 times 2, and then x to the negative 4th, y to the 19th. And the last thing you have to do, simplify the polynomial. So the only thing that's going down again is that x to the negative 4th. So it's negative 34, y to the 19th over x to the 4th. Alright. Then same as 10 here, simplify on the inside. So I kind of rewrote my fraction, it'd be 1/2, that's what the 14 and the 28 simplify to. And then I can cancel 12 of these from the 20, so there's 8 left up top. Cancel 10 of these from the 14, so there's 4 left on the bottom. x to the 8th, y to the 4th, and then I have a 4th exponent outside. It's kind of hard to see. We multiply exponents, so it's x to the 32, 8, because you distribute that to all of those, and then y to the 16th. That's your final answer. Okay, down below, evaluate the polynomial. This is just simply you plug it in. Okay, you plug in the 2. I plug in 2 first, and then I plug in 4 next. Okay, so it look like this. P of 2 equals, I'm only going to do the 2. Alright, 6 times 2 to the 4th plus 4 times 2 cubed minus 3, 2 squared plus 8 times 2. Alright, so I just plugged in 2 for all the x's, and now I'm going to evaluate. So 2 to the 4th, that is 16, so it's 6 times 16 plus 4 times 2 cubed, that's 8. 2 to the 4th, that's, or 2 to the 2nd, sorry, that's 4. Plus 16 plus 15. I'm going to keep simplifying here. So 6 times 16, that's 96. 4 times 8, that's 32. Minus 12 plus 16 plus 15. So 96 and 32, that's 128. Minus a 12, that's 116. 132. 147. So P of 2 equals 147. And this is mental math. I'm hoping I got it right. The process is it's the same. I just might have my mental math right and I don't have my other answer key in front of me. Okay, the one down here is the one that was a little bit harder. So remember I said we had to kind of look at the two different pieces. So we had this piece right here and then we had that piece right there. So we need to do f of x minus 3. So that means you take x minus 3 and you plug it in for all the x's that you see. So I kind of did this in class. So I did this piece first. So f of x minus 3 looks like this. Alright, so we plug in the x minus 3 and that should be a squared. And then the negative f of 3x would look like this. So I'm going to multiply everything by a negative 1 and then put a 3x in for all the x's that I see. So this would be a negative 4 times 3x squared minus 3 times 3x plus 3. So I just changed all the signs here. Alright, and once I evaluate both of these, then I'm just going to add them together. Okay, so this one would turn into this, x squared minus 6x plus 9 plus 3x minus 9 minus 3. So I multiply everything by a 4 in here, so it's 4x squared. That would give me a negative 24x. So then I would add that to that, so it's a negative 21x. And then this would give me a 36. So 36 minus 9 is 27, minus 3 is 24. Okay, so I have that, and then I'll simplify this one. Okay, so then we get a negative 36x squared minus 9x plus 3. Now I'm just going to add these two together. So I'm going to add this one with this one to get my final answer. So 4x squared minus 36x squared, that gives me a negative 32x squared, negative 21, negative 9, so that's negative 30x, 24 and 3, that's 27, and then that is your final answer. Okay? That's the best way to do that. Easiest way to do it. Alright. 2 on the bottom. So I could do synthetic division, but I specified here I want you to do long division. You're going to have to know how to do both on the test. I'm not going to do this one because I may need a calculator for that one. I will do this one because it's a little bit smaller numbers, but we will see. So we look at this first, okay, and you set that equal to 0. That's what's going to tell you what you need to put in the box. So I'm going to put 8 in my box off to the side. Alright, so it looks like this. And then the numbers that go in here are my coefficients. So 10, negative 85, and then a negative 10. And I don't, oops, I need long division, sorry. Cross that off, long division, redo. So x minus 8, 10x squared minus 85x minus 10. The thing that you have to remember when you're doing long or synthetic division, don't forget to add placeholders where needed. That's for both of them. So if you're missing, say we had an x cubed and we were missing an x squared, then we'd have to have a 0x squared in there somewhere, alright? But these ones are both good, so you don't have to add any placeholders in here. So let's just start with our long division. So we want to say, what can I multiply this x by to make it match that first term there, that 10x squared? Well, you should recognize I can do a 10x. Okay, if I use a 10x, that's going to get me to match. So then I just multiply it through. 10x squared minus 80x. And remember, after I write this stuff down here, right now it matches right away. So you can't, if you put these together, it'll give you 20. So remember, we want to subtract them like that. So that way these cancel. So then we have a negative 5x minus 10 for our next one, because we have to bring that 10 down. So what can I multiply x by to make it match a negative 5x? So that would be a negative 5. So then I multiply it through, negative 5x plus 40. Change my signs, and then those cancel. I have a negative 50 as the remainder. So remember, if we have a remainder, like this, we say plus my remainder, which is negative 50, over what I divided by. So that is your answer. If you did synthetic division, which you should have done long division, so sorry I started that, you should get the same exact answer. Alright? So, next page. Looking at these ones. Okay, I'm going to skip around here. So, synthetic division, I can do these quick. So, if we're looking at the problem like this one, synthetic division, I'll get this one set up. And this one will be similar. Remember, you're going to set this equal to 0. This one is a little bit different because we have that 2 out front. Alright, so remember, when you have a number out in front of your variable in your binomial, you have to divide everything by that number. So that means each of these terms have to be divided by 2. Then you can do your synthetic division. So I'm going to rewrite this up above after I divide it by 2. Okay? Move my papers around here. So divided everything by 2, I get 3x cubed minus 42x squared plus 132x minus 120 divided by x minus 5. Okay, now I can do my synthetic division. So I'm going to use a 5 in my box. 5 in my box. My coefficients are up here. We use these ones. So 3, 42, 132, negative 120. That should be a negative 42. Okay, so the first one comes down. I'll rewrite that 5 so you can see it a little bit better. First one comes down. 3. That gives me a 5 times 3. So it's 15. So I get a 27. 30, 42, yep, so negative 27 times the 5, that's 135, but it's a negative. So remember, when I write these numbers up here, I'm adding down. So that's where that negative 27 comes from. I add down up here. So if I add down here, 132 minus 130, or plus a negative 135, gets me to a negative 3. Which gives me a negative 15, and then my remainder is negative 135. So before you're actually done here, you have to write this back out as a polynomial. Alright, so this would be, since I started with a cube, and I took out an x, that's going to be a 3x squared. So 3x squared minus 27x minus 3 plus negative 135 over... we could do x minus 5. Actually, I think we have to use the 2x minus 10. And then that is your final answer. This one over here should be a little easier. Okay. For 19 and 20, those should be fairly simple. All right. You could have checked them with Desmos while you're working on them. I'm not going to take the time to graph them completely, but I'm going to get you started here. So remember, when we do these, the instructions pretty much tell you how to do it. So it says graph the function to the right, so on the graph, by making a table of values, identify important points, max, min, 0 on the graph. So we needed to start with an XY chart, and we wanted to go from -3 to +3. All right, and then when we graph those, we have to see if that gives us enough information. All right, so some things I can look at the graph to see if I did it correctly. I look at my leading term, so it's 6x to the 5th. I know that this is an odd function. So if I think about end behaviors, I know they're going to be opposite directions. All right, 6 is the positive, so I know it's going to be it's going to go somewhere up here and somewhere down here because it's going to be a leading coefficient, which is positive, so I go up to the right, down to the left. And the same exact thing for this next one down here, 5x to the 5th. It's going to go up to the right and down to the left. So it's going to end up something like that. There are some curves and stuff in between, but that's the point of the XY chart. All right, you should have been able to look that up in class to get your numbers. And if you absolutely cannot get the correct numbers, email me later, and I'll help you out a little bit. Okay. So the one down here on the bottom says use an XY chart for the given function to find the consecutive values of x for which each real 0 is located. So that just means exactly what it is. You make an XY chart. But remember, we're looking on the XY chart for where numbers switch from negative to positive in the y values. So if I make an XY chart, I guess I could have done it sideways. I'm just going to start at a -4 just to see if we need it. And I'm going to cheat here and grab my graphing calculator. If you're not getting the correct numbers, remember in class, whenever we put one of these numbers in here, you had to put it in parentheses. So we said -11 times x to the 4th, so it's -4 to the 4th minus 5, -4 cubed minus 9, -4 squared plus 12. Kind of like that. I have to put it in my calculator exactly like that with parentheses and everything around it. That way I am graphing or using the correct function. Okay? So I'm going to use my graphing calculator quick and then put in my numbers in my XY chart. Those are big numbers is what it looks like. So I don't need the 4 because it's a huge number. So it's -863, -186, -17, 10, -3, -218. And the other ones are huge, so it's not necessary. So looking at this function, okay, remember how we could determine if it's going to have a 0 or not. So we're going down, or this would be going up from this one to this one. So it's going up, up, up to a 10, back down to a -3. So we can say that this is a maximum because that went up to that point and it's going back down. But really we're looking for where it goes from positive to negative or vice versa. So we are here to here, here to here. Those are where they change the sign. So negative to positive, positive to negative. So we could say it's between -1 and 0, and then 0 and 1. That would be where the consecutive zeros, or the consecutive integers where the zeros lie. Okay? Alright, almost done here. Last page. Looking at the last page here. 22 is exactly like the last one, 21. So I kind of explained how to find a maximum or a minimum. So you'd be seeing if the values go up to a certain number, then start to decrease. So let's take a look at that one quick. I can show you with this one. So these were all my numbers for my last one. If I want to find a maximum or minimum, you can say that these values are increasing up to here. Once I get to that 10, then they start to decrease again. So that means this must be a maximum, because maximums, right, they go up to a value and then they go back down. So my values are increasing and then decreasing. That's how you can tell it's going to be a maximum. If it were the other way, so say this, I'd be going down and then back up. This would be a minimum. This would be a maximum. Okay? That's how you tell. So make an XY chart with this guy right here. Look for values to go up to a certain point and back down, or vice versa. Okay. A few more here. So factor the polynomial. So let's use SMILE method grouping and sum of cubes. I'm not going to do 23. That's SMILE method. You should be able to figure that one out. 24 and 25 are the ones I will do, because they are the new patterns. And I gave you sum of cubes or difference of cubes. I'll give you this on the test or the quiz. But we need to figure out what our A and our B are first of all. So looking at this one, we have to say, what's the cube root of 216, or is 216 a perfect cube? Well, yeah, that's 6x, so that's my perfect cube. And then this one would be 5y. Once I figure that out, the rest of the pattern is right up here. Okay, so this would be my A and B that I have written out here, and then the rest of the pattern is off to the right. So the other thing I said in class was SOAP. That helped me remember the signs. Okay, so if I wanted to memorize the pattern, so I have a small set of parentheses with 2 of them, and then I got 3 of them over here. So I square the front one, 36x squared. Square the back one, it goes in the back. So 36x squared, 25y squared. And then the middle one is these two multiplied together. Okay, so it's 30xy. And then signs are same, opposite. So same, opposite, always positive. So it's 6x plus 5y times 36x squared minus 30xy plus 25y squared. That's all you can do on that one. After you're done with the pattern, then you are done factoring. Okay? That's what's nice about cubes. Use the pattern, then you're done. 25 is grouping, so I split it in half, and I did a greatest common factor of the left and the right. So on the left, you should see that you can take out a 15y. So if I take out a 15y, I'm left with 2x minus 3. And then I take out over here, I'm going to take out a 4. I'm going to take out, so let's see what we get if we take out a 4. So you can kind of see that I'm going to get a negative 2x in the parentheses, but I want a positive 2x, so I'm going to take out a negative 4. And then I'll get 2x minus 3. So I should see that I have the same thing in the parentheses here as I do here. When they are exactly the same, okay, the order is okay. It doesn't matter the order. I could have negative 3 plus 2x, negative 3 plus 2x. That doesn't matter. Once they're the same, then that is my new greatest common factor. So now that goes out front. Just like I did the 15, but now it's going to be the 2x minus 3 is out front. And then I would have that gone and that gone. So I have 15. That should be a 15y. Sorry. 15y minus 4 in the other parentheses. Okay? Once you do that, you look and see if you can do anything else. I cannot take anything else out, so that is my answer. Those are my grouping answers. Okay? A couple of these down below, these ones are probably just a matter of review. Okay? A matter of you looking back at your notes, because it's a pattern, so it's not like I have to show you exactly how to do it. You have to memorize the pattern. So the first ones here we use Pascal's triangle. Remember, Pascal's triangle is this guy over here. One, 5, 10, 10, 5, 1. And remember, Pascal's triangle starts at n equals 0. This is 0, 1, 2, 3, 4, 5. So those are the levels of Pascal's triangle right there. Okay. And then I'll just do this number 27 here quick. So expand the given binomial using Pascal's triangle. So it is a, well, I'll do 28. 28 is a little bit harder. It's a 4th degree polynomial. So that means we are going to use the 4th row, or n equals 4 in Pascal's triangle. So that's a 1, 4, 6, 4, 1. So the first term is always the first term to the 4th power, first term to the nth power. So 2k, I have to put it in parentheses to the 4th power. And the second term is where that second term comes into play. And then we use Pascal's triangle's number. So it should be, this should actually be a 1 out front. We don't ever write that. It's not really necessary. So the second term, I go to the 4 right there. 2k. Remember, this exponent goes down by 1. And then now my second term goes up by 1. Or it starts there. It begins. So then the third term, I'm at the 6. 2k to the second, negative b to the second, and then a 4, 2k to the first, negative b to the third, and then 1 with a negative b to the fourth. Okay, last thing you had to do is just multiply all that out. So 2 to the fourth, that gives me a 16. So 16k to the fourth, 2 to the third, that's 8. So this was 8k cubed, so this gives me 32k cubed. Oops, sorry, but it's that minus b in there. So this should be a minus. So it's minus 32k cubed b. I started to write an exponent there. That's not right, though. So, because this is the first power, I don't need to write the first power. All right, then this one would be, so 4k squared. 6 times 4, so that's 24k squared, b squared, because a negative b squared, that cancels out to just a b squared. And then we have 4 times 2k, so that's 8k, but again, this is a cube for the b, so that should actually be a minus. And then the last one will be plus b to the fourth. So sorry about the scribbles on that one. Alright, and then one of these guys down here for the last one. So find the specified term of the given binomial. Remember, this is the combination stuff where we had the combination, whatever this power was, that went there, and then this one was the difference between the two above that. So both of these are pretty simple. If we're looking for the 4th term or the 6th term, whatever term you're looking for, you remember you subtract 1, so this is 4 minus 1. So I'm going to use n equals 3, or I'll use r equals 3, sorry. The n matches the 5. Okay, so this would be 5c3, you've just given that. And then now I have to put each of the terms in parentheses. So it's 10k goes here, and then a negative m goes there. The negative m matches with the 3, and the 10k matches with the difference between the two. So it would be a 2. Okay, so 5c3, that would be, I can use Pascal's triangle. 1, 2, 3, 4, that's 10. So this would turn into a 10. So 10 squared, this would be 100k squared. So then this would be a negative m cubed. Multiply all three of those together. We get negative 1000k squared m cubed. And I'm not going to be super picky on the order that you write those. Just if you write it in the order that you write it in the pattern, that's okay. Alright, so that's exactly how you do 30. Rather than using a 6, we'd use 6 minus 1, which is 5. So it would be 8c5 x to the something. We'll fill it out here in a second. Before y to the 5th, this would be to the 3rd. So whatever you get from that, when you multiply it out, that would be your answer. Alright? So that's everything in your review guide. If you got questions tonight, send me an email. We'll take some time in class tomorrow to review some of these. We'll probably review for 15 minutes or so, then I'll give you guys your quest. And then I will give you guys some time after the quest to review for the midterm. And then we'll spend time reviewing for the midterm on Thursday. Okay? So email me if you got questions. Have a good night.